All right, let's summarize Unit 3. This was a shorter unit about rational functions. Rational functions are the ones that have the variable in the denominator. So the first thing we looked at was, well, when you have a variable in the denominator, you have some undefined values, you have some asymptotes because of the fact that you cannot divide by 0. So we called them, how do I find undefined values of an expression? So that would be another way of finding the asymptotes. So that is basically asking what makes the denominator 0. What makes the denominator 0? Because we cannot divide by 0. So that's where it's undefined or it's unknown. So for example, let's say it was 1 over x plus 5. Well, what would make the bottom 0? I could set it equal to 0, and I'd get x equals -5. So the undefined value would be -5. And then how do I add or subtract rational expressions? Well, the first thing is to make sure they have a common denominator. That's our first step right away. Okay. Once we know that, okay, they don't have the same denominator, so if one was x plus 1 and one was x minus 5, then we multiply them by each other. Multiply them by each other and then simplify them and finish it off. So we are not solving unless there's an equal sign. All right, next one. How do I match graphs to equations and asymptotes? In class, the first thing we did was check the asymptotes first. Okay, so check what those asymptotes on the graph are. Look for the x equals and the y equals, and then eliminate some options from those multiple choice. And remember that x equals a number, that's going to be vertical. And y equals a number, that's going to be horizontal. Okay, once you get those, then you just have to match it to the equation. And matching to the equation means this is the undefined value. So if this was -5, I'd be looking for this equation. If this was +5, I'd be looking for one that has a minus here. How do I solve equations with rationals? Well, we had a couple of methods, and the first one was to cross multiply. So we cross multiplied them, and then we checked if it was just like an x with no squared, then we just solved it. And if it had a quadratic, something with x squared, then we had to factor it. We also had some that were larger, like x cubed or y cubed, and for those, we tried to graph them, or we looked to see could we factor them. So that would have been where we looked for, when you see something that says look out for extraneous solutions. That's a hint to you that if there's something extraneous, then you probably just want to factor the bottom. So the questions would say eliminate extraneous. That means that you do not want to select that answer. Do not select that answer. Because extraneous means that's the number that made it 0 in the bottom. So like up here, if you got an answer of -5, that would be extraneous because it's undefined. So when you get a question that says eliminate extraneous solutions, that would be where you are going to factor it and cross out, or sorry, simplify so that you end up with the denominators being the same. Then you can set the tops equal and make sure at the end you decide which answer is the good one. And that is it for rational functions.